This insane 6th-generation fighter jet shocks the world. The 6th-generation fighter jet is set to revolutionize the skies, leaving its predecessors in the dust. But how does the 6th-generation fighter jet fit into the broader landscape of global military competition? It's no surprise that the Navy and Air Force are eager to bring this beauty to life, with unmatched capabilities in speed, stealth, and air superiority. But how crazy is this new craft? And what type of shockwaves will it cause in the world of military aviation? Join us as we unravel the mysteries of the 6th-generation fighter jet and what it implies for the future of air combat. So, why is there so much speculation going on about the new 6th-gen fighter jet? The Navy and Air Force variants of a 6th-generation, next-generation air dominance or NGAD stealth fighter are swiftly approaching completion and not a moment too soon. Given that the current threat environment calls for a quicker, stealthier, and significantly more lethal fighter jet. But how is it even better than others? To know everything about this jet, you have to stay tuned to our video till the end. It is important to note that through ongoing software improvements, the F-35 may well remain dominant into the 2070s and beyond. In short, the F-35 appears to be capable of staying ahead of threats for decades. However, this does not mean that a 6th-generation fighter for the U.S. Navy and Air Force is not urgently needed for a variety of reasons. The F-35 is a multi-role fighter with high speed, mobility, cutting-edge computing, and 360-degree surveillance capability. Characteristics that make it a suitable partner or supplement to an ultra-fast, ultra-stealthy 6th-generation stealth aircraft. In terms of air superiority and speed, a 6th-gen craft will be more of an F-22 replacement, but many of its advancements will be in the realms of manned-unmanned teaming and command and control. New data links, command and control technology, and AI-enabled data analysis will enable a 6th-generation family of systems in which a single manned platform operates 5 or 6 drones at the same time. According to Air Force Secretary Frank Kendall, the notion of a 6th-generation fighter, or NGAD, is one of the service's primary operational imperatives in which a family of aircraft will execute a variety of duties. There are far too many critical features for a 6th-generation fighter to list, but AI-enabled targeting data analysis, sensor range, and fidelity will have to be paradigm-shifting. If a 6th-generation aircraft has long-range and high-fidelity targeting sensors similar to the F-35, it will be able to observe and destroy enemy targets from standoff ranges before it has seen itself, resulting in significant overmatch. The platform's capacity to communicate with ground command centers, drones, other fighter jets and ground vehicles, Navy ships, and even satellites will allow it to collect and interpret time-sensitive data required to move in, attack, and destroy a rival. While speed and maneuverability are important, it is expected that long-range sensors, networking, high-speed AI-enabled computation, and weapons guidance will be what distinguishes the 6th-generation fighter from competitors. The current threat environment, which includes the appearance of a Chinese J-20 and J-31 and the Russian Su-57, is driving the urgent need for a 6th-generation aircraft like the NGAD. While there is no strong evidence that these platforms are superior to a U.S. Air Force F-22 or F-35, their existence undoubtedly adds to the necessity to keep ahead of great power rivals. China and Russia already have a considerable number gap in 5th-generation aircraft, but the characteristics and precise performance parameters of Russian and Chinese aircraft may be a mystery. All the more reason to harness breakthrough or disruptive technology. Hey you soldier, we need 1 second from you, so please drop your bum on the subscribe button and be part of our exclusive military family. Of course, planning and technology details about the FA-XX are unlikely to be revealed due to security concerns, but conceptual development on the fighter has been ongoing for many years, and the Navy's 2024 budget requests up to $9 billion in funding for the new plane. The requests are stretched out over the next 5 years, but an essay in The Drive suggested that this could be an indication that prototypes or demonstrators are on the way. This is not surprising given how successfully the Air Force, for example, has used digital engineering to accelerate weapon platform design, development, and manufacturing. Advanced computer simulations can now perfectly reproduce critical weapons performance aspects, allowing weapons developers and innovators to swiftly and efficiently examine a variety of possible designs and performance specs of a given weapon system. Along with the Air Force's 6th-generation aircraft, the Sentinel, the service's new intercontinental ballistic missile arrived ahead of time, thanks in large part to the successful application of digital engineering. According to senior Air Force weapons researchers, digital simulations allowed engineers and analysts to evaluate 8 or 9 alternative ICBM models before determining which ones to manufacture. This was crucial since the Air Force didn't have to build 10 different prototypes and bend metal as much to find the best designs. Given the success of digital engineering across numerous significant weapons platforms thus far, it appears entirely possible that such advancement accounts, at least in part, for Navy progress and funding increases with its FA-XX aircraft. If they haven't already, protesters may take to the skies. The FA-XX, which is intended to operate alongside and eventually replace the FA-18 Super Hornet, is projected to break new ground in the field of carrier-launched stealth aircraft. Although many of the exact technologies are unlikely to be accessible, industry and Pentagon weapon developers have recently detailed a number of potential needs, operational ideas, and technologies that are likely to inform Navy 6th-generation development. The utilization of multiple drones, drone swarms, or other unmanned systems, AI-enabled networking, new generations of sensing and targeting, and the ability to communicate real-time combat data with existing 4th-generation aircraft are some of the important topics that spring to mind. The Pentagon, Navy, and Air Force, for example, are all rapidly developing technology that allows manned stealth fighters to control several drones from the cockpit, maximizing attack speed and enabling survivable advanced reconnaissance. When guided by a person, a carrier-launched 6th-generation might, for example, order many drones from the cockpit to test enemy air defenses, blanket an area with reconnaissance, or even conduct strikes. The aircraft will very certainly integrate new stealth paradigms in which heat signatures and radar return signals can be considerably reduced, if not altogether avoided. Former Chief of Naval Operations Admiral Jonathan Greenert stated several years ago that whoever controls the electromagnetic spectrum will likely win the battle. The Navy's 2024 budget records reflect this emphasis since huge sums of money are allocated to spectral dominance in the 6th-gen FA-XX stealth fighter plane. Lasers, EW weapons, and RF countermeasures are all planned to play a role in NGAD, according to Navy and Air Force budget documents. The Air Force's budget request for fiscal year 2024 includes studies to develop operational/system architectures to include the family of systems and spectral dominance platforms, jamming weapons guidance systems, blinding an enemy's targeting sensors, crippling communication systems, and interfering with radar systems are all essential future warfare objectives that electronic warfare systems might potentially execute. Given the increasing reliance of networks and weapon systems on electronics, dominating the electromagnetic spectrum is quickly becoming a highly valued area of future military effort. If an EW interferes with or jams the RF guidance of a precision-guided weapon, the weapon cannot reach its target. Because of rapid technology advancements, EW is finding new uses. To quickly identify which signals to jam, spectrum information can be reflected off of a database. Sensors and communication devices can also be programmed to emit a more narrow or streamlined pencil beam kind of electromagnetic signal. This is crucial because a larger or broader electronic signature can reveal an enemy's position, yet a more targeted beam can deliver an effect without producing a significant signature. When it comes to weapon guidance systems, researchers are working on a technology known as frequency hopping to counter electromagnetic jamming. If one frequency becomes jammed or interfered with, weapons guidance systems can be programmed to hop from one frequency to another in order to maintain their track or direction to a target. It is vital to harden networks, data links, or communication systems to operate in a jamming environment in order to maintain operation in a contested EW environment. EW can be crucial in the arena of manned-unmanned teaming for 6th-generation aircraft, as both the Navy and Air Force want to run a family of systems in which manned fighter jets control neighboring drones from the cockpit. Forward-operating drones can use this to jam opposing air defenses, overwhelm communications, and transmit key targeting detail across formations. Passive EW may essentially listen to an enemy's electronic communication to determine a line of bearing to locate signals to monitor or jam, but active EW can emit a signature to block, jam, or interfere with communication. Platforms are also increasingly adopting omnidirectional antenna to direct an electronic signal in a specified direction rather than creating a huge 360-degree trace that an attacker could detect. These applications are essential to the Navy and Air Force's plans for 6th-generation manned-unmanned teaming, known as Combat Collaborative Aircraft or CCA. The idea is to connect a family of systems in real time by deploying drones in close collaboration with manned fighter platforms to conduct forward surveillance, test enemy defenses, ensure precision guiding, harden targeting sensors, and even deliver missiles. We have reached the end of today's video, but no worries. If you want to stay up to date on the latest war developments, make sure you press that bell icon.